Okay, so in this example, this is a think, pair, share because the previous examples, had everything kind of presented to you, kind of guiding you through the whole process. This is an example where you have the problem. I've put out the questions to answer, but you'll see right after that, it's just blank space. All right. So this is where you go through and you try and do this all on your own, without the help of all of that scaffolding that I've provided earlier. So what we're going to do, if you haven't tried this yet, please try and go through it on your own, and then come back to this video as I work through this. Okay, you can work through it with me. Again, you can pause this video at any time. Uh, it's important that you try and exercise your brain and kind of do this on your own with as little help as possible. All right. So let's take a look. In Europe and Asia, I think that should have been e-commerce is popular. Change that there. Okay, e-commerce is popular. Don't know what do I mean by that? So see that. E-commerce users have special mobile phones that work like electronic wallets, as well as provide phone and internet services. Users can do everything from paying for parking to buying a TV set or soda from a machine, to banking to checking sports scores on the internet. So here we got a year, so the year 2000, 2002, 2003, 2004, and the number of users in millions. Now this extra column here, this is actually, kind of like a good technique to show that if you're ever dealing with years, okay, like year 2000, year 2002, 2003, it's usually best to consider the first year to be year zero. And this 2002, I think I need to change this. So I think this needs to be 2, and this needs to be 3, and this needs to be 4. Okay, because from year 0, 2 years later would be 2002, and we had 20 million users. And then from 2003, from year 0, that was 3 years later. Okay, so I think I caught a little bit of an error there in this example, but I fixed it. Okay, so for the years 2000 through 2004, was there a relationship between the year and the number of, change that to e-commerce users? Work through the following 4 questions. So does there appear to be a linear trend between both variables? So note, hand sketch a scatter plot. Question 2, what is the literal strength of the line of regression? Question 3, does the line of regression estimate the sample data with at least a 99% confidence level? Question 4, does the sample line of regression model the population line of regression with a 99% confidence level? All right, so let's go ahead and start tackling this one. So here we're going to look at question 1. All right, and so question 1 is we're looking to see if there is a linear trend. Okay, we're going to do a hand sketch. So let's see here. So let's do a quick little XY axis. And let's look and see what's going to be our independent variable and which is going to be our dependent variable. So usually year is going to be your independent variable, and the number of users here is going to be your dependent variable. So our X and Y there. So you can see our values of X are going from 0 to 4, and our Y values are going from 0.5 up to 47. So we might want to go from 0 to maybe 50 on the y-axis, and 0 to 4, 0 to 5 on the x-axis, maybe. So on the x-axis, we're going to go from 0, and let's do 1, 2, 3, 4, 5. Okay, and this is going to be year number. So let's call this year number. And let's see here. This is going to be from 0 to 50. So we got 0, 10, 20, 30, 40, 50. Again, this is a hand sketch, so we're just kind of doing the best we can here. This is going to be the number of users in millions. And let's go ahead and plot our data. So we have these ordered pairs. So we have the ordered pair 0, 0.5. We have the ordered pair 2 and 20. Then the ordered pair 3 and 33. And then the ordered pair 4 and 47. Okay. So let's take a look at what that would look like here on our graph. So we've got 0 and 0.5. Okay, so that's going to be really low down there. And then we've got 2 and 20. And then we've got 3 and 33. So it's going to be just above 30 there. And then we're going to have 4 and 47, just be somewhere right about there. All right. And let's see here. So, at this point, question one is, does there appear to be a linear trend between both variables? And I would say the answer to question one here is going to be yes. Let me put this in a different color so it stands out a little bit better. So answer one. So it's going to be yes. Qualitatively, it appears that as x increases, y increases linearly. All right. And the other point that we want to do here too is let's get our mean point, right, which is the point x bar, y bar, and that's calculated. So let's do that really quick. Now, because I just now caught this error in this problem, I had the calculators already pre-ready to go, but I'm going to have to now change what I had. So Texas Instruments will go to the list editor, and you can see I've got to change these years to be 2, 3, and 4. But you can see there's my list of x values. There's my list of y values. And we want to go to two variable stats. So I'll click the stat button, go to calc, two variable stats. Okay, list one and list two for the x list and the y list. We'll hit calculate. All right, so we've got x bar of 2.25 and y bar of 25.125. All right, so 2.25 and 25.125. All right, so let's see maybe where this point is going to be. So we're going to be at about 2.25. So there's 2.5. 2.25 is going to be in between that. And then 25.125. 125, which on my sketch is going to be pretty much on what looks like 25. So where those two come together, that's going to be my X bar, Y bar mean point. All right. Um, so if we're going to also sketch a line of regression, okay, we're going to sketch it to go through our mean point. And I'm going to label this line of regression. It looks like our line of regression will have a positive slope, right? It's going up and to the right. And remember, slope is equal to the rise of a graph over its run. And so, so if we go from one point to another point, so if we went from this point, we would have a run of a positive x going in the positive direction. So we're going to have a positive x run. And then to get up to the next point, we're going to go up, and that's going in the positive y direction. And positive over positive is going to be positive. So that's where we get the fact that the slope is a positive number. Plus, looking at it, it's going up and to the right. And if we look at how closely, these scatter plot points are to this line of regression line, we can see that the scatter points are pretty tightly bound. So scatter points are maybe tightly bound to the line of regression, which implies that our correlation coefficient R, we're going to expect that to be high or close to 1. And it's going to be a positive 1. Let me erase that instead of trying to squeeze that in there. Come on, computer, catch up with me. Okay. Let me delete this just to make it clear. So it's going to be approximately, very close to a positive 1. Because remember, the sign of the correlation coefficient will have the same sign as the slope. All right, so when we get into the later questions and answers, that's what we're going to be looking for. All right, so what I got to do here first is, down here I put the answer, and since I made that change, my answer is going to change. So please bear with me as I make this change now while I'm thinking about it. And let's go ahead and just put this into our calculators and graph them. But one thing that I realize I haven't done yet is if we go to the numWorks calculator, how do we get X bar, Y bar, right? So we want to go into the regression app. And then this is where I put my list of X values that I need to now change. All right, and then there's my list of Y values. And if I just want to get X bar, Y bar without anything else, I could just go to the Stats tab. And then right here where it says mean, X bar, this will just give me the mean of each column. So you can see the mean for the X values is 2.25, and the mean of the Y values is 25.125. Okay, so that's how we can get our mean point using the numWorks calculator as well. But let's go ahead and take a look, at these points on both calculators, just to kind of confirm the sketch that we did. So all we need to do is go to, let's go to y equals, make sure we don't have any plots that are going to interfere, and we do. So I'm going to come down here to this one and I'm going to hit clear like that. And I think this plot one, plot two, and plot three, I think this is the stat plot. And let's see, I think, can I turn it off here? Because you can see plot one and plot two are on. If I, see if I click on that, that turns it off. Okay, cool. So I'll just go ahead and turn that one off too. All right, I learned something new today and turn the other plots on and off from here. All right, so let's go to the stat plot. So I'm gonna hit second and then y equals. Yeah, you can see they're all off. Okay, that's fine. So we're gonna go into plot one. Just make sure all the parameters are what we expect, what we want. So I'm gonna turn it on now. List of x values are in list one. List of y values are in list two. Um, I'll leave this as the symbol because I think it'll be easiest for you to see on the screen, and we'll leave the color at blue. And now in order to see it, we want to hit the zoom button and go to zoom stat, which is number 9. So since it's number 9, we can just hit 9 on the keypad, and there's our plot. And you can see this scatter plot, looks very close to what we sketched, here earlier. Now to do the same thing on the numworks calculator, all we need to do is go to the graph tab. And there's our scatter plot. If you want to kind of reposition the axes a little bit, maybe so it's a little easier to see, maybe we would maybe put this between -1 and 5. So we could come up here to, let's see, is it axes? No, let's go back out. If we go up to auto, okay, this auto means it's going to auto scale the axes for you. And so if I click, no, let's see here, if I turn that off, then maybe now I go to axes. It should be, now I can change the values of x. Okay, so let's come down here, and the values of x I want to be maybe -1 to 5, like that. I'll confirm. And then the values of y, they looked more or less fine. I'll change those to be from, let's maybe put -10 to a +50, something like that. Let's see how that looks. Let's go to confirm that. Yeah, so we're going so it's showing -1, but I was hoping it wouldn't put this vertical axis right here. I was hoping it would put it over here, but that's fine. And it went to 5 over here on the x, and we're going from 0 to 50. So that looks okay. At least now we can kind of see more of the graph here. So that's good. If we wanted to do the similar thing here on the Texas Instruments, then you'd click on this window button. And with this window button, this is where you could set the minimum x value and then the maximum x value. I wouldn't worry about scale. Then the minimum y value and the maximum y value to something like that. And then you can just don't hit zoom and zoom stat, because if you hit zoom and zoom stat, it's going to undo all that. So now just hit the graph button. Okay, and now it shows it with that new scaling. Okay. All right, so we've kind of shown how to do both there. Let's go back to this problem. All right, so let's go to the next page where we got some more room. And let's look at question 2. So question 2 is, what is the literal strength of the line of regression? All right, so here I'm going to put, question 2. I'm going to put literal strength of R. So we need two things here. What we need is we need to figure out what the correlation coefficient is, and we need the literal translation table. So I'm going to get that from the previous example. So in order to get the line of regression, or I'm sorry, the correlation coefficient, let me show how to get that with the Texas Instruments calculator. So for that, we're going to use the function linreg ax plus b, and then I'll show how to get it on the numworks calculator as well. So first, Texas Instruments. So we want to go to, I think it's stat, go to calculate, go down to linreg ax plus b, which is the fourth option here, and hit enter. Okay, our list of x values, a list of y values. Okay, list one, list two, that looks right. And I'm going to store this into variable y1 so I can graph this next. So I'm going to click on the vars button, go to the y variables. I'm going to go under function, and I'll store this in y1. And I'm going to hit calculate. Okay, and there's the correlation coefficient with our line of regression. So let me write this down. So our value of the slope is 11.5285. So we're just going to put, I'm going to put 11.53. I'm rounding, and I shouldn't do that. But for the purposes of this, I'm going to put 11 point, oh good, I'll put 5, yeah, I'll put 5.2, and then I'll just say that there's more to it. The y-intercept is given a negative 0.81. Okay. And so that'll give us an equation for the line of regression of, I'm going to put 11.53 because the 2 would have been rounded to a 3, x minus 0.81. So this, I'm just going to make a note, is rounded to 2 decimal places. All right, and we were actually trying to get our correlation coefficient. So the correlation coefficient is 0.996. So I will round this one. So 0.996. All right, now let's really quickly look at this correlation coefficient. And is this what we expected? So remember in the previous part, I said that the correlation coefficient is going to be high, and it's going to be close to +1. And as we look here, it's high, and it's close to +1. It's positive 0.996. So this is what was expected. All right, let's look at the numworks calculator now. And if we want to get our line of regression, we need to choose, what model we're gonna fit to the scatter plot. So you want to go up here to these graph options at the top, go over to regression, click OK. We want to choose a linear model. So it's in MX plus B format. All right. So there it gives us our X bar, Y bar as well. And let's see, I think if I click down, Yeah, uh, here is our slope, and here is our y-intercept. So you can see we're getting 11.528 something. It's what we just got on the Texas Instruments, and we're getting a very exact same y-intercept here. Okay, but it puts a little hat over the y, and I like that. All right, so on the NumWorks calculator, um, you use the regression option in the graph tab. All right, and we get y hat equals 11.53x minus 0.81. All right, but we also want to confirm what the correlation coefficient was. So let's do that too. So we want to go back to the stats tab. So scroll up and then come back down. And there it says correlation coefficient 0.995 or 0.996 if we round it to 3 decimal places. Okay. Now the next thing we need to do is we actually need to translate this, right? So we need to go to the translation table. So I'm going to go to a previous example just so that I can get to this translation table. And so our correlation coefficient was 0.996, which is clearly in this range between 0.8 and 1.0. And so that is going to be very strong. That's the literal description of the line of regression, that it's a very strong fit to the scatter plot. All right, so our correlation coefficient of 0.996 is between 1.0 and 0.80, which means that it is a very strong fit to the scatter plot. So this is what we were looking for. You know, what is the literal strength? What is the literal strength of our correlation coefficient? It's very strong. Okay, so let's go ahead and stop it here at this video. The next video we'll carry on with question 3 and question 4. So at this point, we've already finished half of this problem. All right, let me know if you have any questions.